Well, hi everybody. Thank you, Design Indaba. Thank you for having us. It's great to be back here in Cape Town. Before we start the presentation, we wanted to share something funny with you that happened recently at the lab. There was a burglary. And look at what we captured.
Thanks again. It's a great pleasure to be here in Cape Town. I wanted to go back then to some of the things that our lab does. I'm Italian, and everybody in Italy grows up with a picture with a car like this in their bedroom. And the reason I'm showing you this is that actually something interesting has happened in Formula One over the past 15, 20 years. Now, 20 years ago, if you wanted to win a Formula One race, you had to get a good car and a good driver. And if the two were good enough, then you'll win the race. Now today, if you want to win a Formula One race, you actually need something like this. Something like this, it's a system that's made of thousands and thousands of sensors onto the car. Those sensors collect information in real time. That information is sent to this computer, analyzed, processed, and then decisions are made in real time. Now in other terms, this is what we usually call as engineers a real-time control system, which is really a system based on a sensing component and an actuating component. And that's what every dynamic system does. It's what we all do when we meet each other. We sense each other, we collect information about each other, we touch each other, smell each other, look at each other, and then we respond to that in real time. We make decisions and then actuate. Well, we believe that the incredible thing that is happening today in our cities is that actually our cities are becoming like that Formula One car. They're becoming like real-time control systems. We layered with many, many networks, digital layers, with sensors, with other type of electronics. And because of that, it's almost as if the digital and the physical layer were becoming the same thing. Bits and atoms, and thus converging, and thus in the middle. Well, we believe at the lab that cities are important because, if you just want to remember four numbers, it's 2, 50, 75, and 80. Cities are 2% of the Earth's crust, but 50% of the population, 75% of energy consumption, 80% of CO2 emissions. So if we can do something for cities, that can be a big deal. And going back to what is happening then at that level, this convergence of the physical and the digital layer, we think that it's that our environment is starting to talk back to us. There was an exhibition a few months ago at MoMA in New York by Paolo Antonelli called Talk to Me, and really about the fact that this electronics is allowing a new interaction with the world out there. And if you want, that's nothing else than every atom out there becoming both a sensor and an actuator. Nothing else than the old dream of Michelangelo. There's a story goes when Michelangelo sculpted the Mose, he took a hammer, he threw it at the Mose, there's still a little chip on the knee, and he shouted, "Perché non parli?" Why don't you speak? Today, for the first time, our environment, our buildings, cities, objects can speak back to us.
Thanks, Carlo. Well, going back to sensing and actuating, let's focus a little bit about sensing. In this project, we decided to focus on waste. There are many opportunities that emerge when our environments become cyber-physical. When digital stuff merges with physical things, we can register information about how things move around, how people move around, emissions. In this case, we got inspired by global supply chains initially. Look at this map. Look at how complex a system we've put together over the past 30 years. For example, to bring this computer to MIT. Look at how many countries participated in making this. Parts got produced somewhere, assembled elsewhere, then shipped. It's a complex process that put this computer together. But then, when we throw it away, we have some sort of a belief that it's taken care of all right, but we don't really know what's happening to it. So to study this, we partnered with Waste Management. It's a big waste removal company in the US. With Qualcomm, they make cell phone technologies, Sprint, a cell phone service provider, the city of Seattle, and the Architectural League in New York that commissioned the initial study. We developed this little sensor. It's almost like a stripped-down cell phone. You charge it once, and then for 1 year, it would tell you anywhere in the world where it is. And then we invited 500 households in Seattle to collect trash, based on almost like a wedding wish list of trash that we prepared together with a recycling expert. Then we went to their homes to tag their waste. We actually stapled those sensors to pieces of waste, anything from a rotten banana to a used-up fridge. I think people at the Seattle Public Library are still angry at us because it smells still today. They hosted us there for the project. And this is what we saw. So this is the day of the deployment. People threw it away, 3,000 items in total. You see Seattle, 2 landfills in Oregon below, above is Vancouver where things leave the country from. And then the longer traces are primarily electronic waste. Look at the distances involved. Some things went to Southern California, but sometimes via Chicago. Cell phones went to Florida here. So there's an obvious tipping point where the damage due to emissions from transport actually outdoes the advantages of recycling. And this is an example that really shows us how, by instrumenting lightly our environment with digital devices, we can highlight some invisible systems. And we thought that the Farewell Symphony would be something good accompaniment for this. We can also look at user-generated content. So think about the tweets, the web pages we create, the photos we take. We can take that information and use that to actually describe the environment. In this case, we looked at Flickr photos. Many people, when they upload their Flickr photos, they attach a GPS tag to it. Sometimes they say what they did. Here we're looking at tourists in Florence. And we're asking, can you actually create a map that would tell us where do people hang out? Where do most tourists go? I mean, and we saw the places that most of us know. You can see Ponte Vecchio there and the Duomo, Santa Maria del Fiore. You can also start to make comparisons. Who can guess here which map represents the places that Americans visit when they come to Italy versus the places that Italian travelers visit? Make a guess. Yeah, so you can see the sort of places that most of us know, the iconic places in Italy, versus a much more complex network of places that shows where Italians visit when they explore Italy. You can do more fun things. In this case, we're looking at Barcelona, and by parsing the tags that people attach to the photos they take, we could ask, where are the parties? You can create this heat map. Actually, there are parties everywhere in Barcelona, but you can create this heat map that would show you where people go out to party. Here we made a comparison. Some people disclose where they're from, so we compared the presence of people from Britain to the locations of parties, and we believe there's a striking similarity between these two maps. and here, this is already slightly more involved analysis. So not only the tags that people attach to their photos tell us stories, but we can also analyze the content of images. So here we're looking for the color green in each photo, and we're asking, can we use this to tell us how drought spreads itself from east to west as summer enters in Spain? You see green turning into brown, and you can really develop a very intricate pattern of the spread of drought. We can think about this almost like borrowing everybody's eyes to tell us something about the environment we live in. And this is part of a project we're doing in Singapore. It's a big project called Future Mobility that we share with several other teams at MIT. Our part of it is called Live Singapore. And the focus of this is to really look at all these networks that service our cities, from cell phones to mobility. We partner there with our biggest cell phone service provider that gives us information in real time, with a port, with the airport, the Land Transport Authority. They have sensors under the ground. There's a smart grid experiment in the southwest. All this information comes into a platform, an open platform, where it's being combined, and then we extract new knowledge about mobility in the city so that we can actually make the city move more seamlessly, so that we can allow people to traverse the city faster in a more environmental friendly way. For example, in this case, you're seeing 12,000 taxis being tracked in real time, and we correlate this with local weather data. It's very simple, but in Singapore, it's a tropical place. People want a taxi as soon as it rains, and it could be dry around the corner. The taxis could use such a thing, for example, to locate themselves better. This is about first 6 months out of a 5-year-long project that we're doing.
And so we saw a lot of examples of sensing, how today we can use this technology to understand our cities, our buildings in a different way. But if we go back to the sensing and actuation, go back to the Formula One example, what you want to do in the end is win the race. What you want to do is actuate, is respond to all this information. And how can we do that? Well, one way to do that is actually to take that information and share it with people. Share it with all of us. So what you see here, it's a project we're doing with SNCF, the French railway company. And this is Paris, and it tells you how long it takes to go to different parts of Paris if you take different modes of transportation, by bicycle, by metro, or by car. So the city becomes smaller as you move faster by car. But if you look at CO2 emissions, for instance, it's this. It's exactly the opposite, the bicycle, the metro, and the car. So what we started doing and looking at with the SENSEable was, can we actually quantify that? We call the project CO2Go. Can we actually have a way to quantify CO2 emissions, which are a third of all the emissions generated in the world? And the important thing is there's many websites that can allow you to do that, to get CO2 emissions at the end of the day. If you tell the website you've been, say, 1 mile by foot, 1 mile by bike, 1 by car, taking a plane, but that's very difficult. You don't do it at the end of the day. Is there any automated way we can do this in real time, just based on normal technology? And most of us have actually a smartphone in our pocket, and the smartphone has a lot of sensors, GPS, accelerometer, internet, microphone. So can we use that and use that in order to automatically detect CO2 emissions? In this case, what you see here is actually how your cell phone sees you when you're doing different things. So that's accelerometer in your cell phone, how it sees you when you're on a bus, walking or biking, metro. If you were on a horseback riding, you'll see the other signature of the accelerometer, different with trotting and galloping. So that's how it sees you. And then from that, you can see and detect in real time what is the mode of transportation. You can detect in real time the calories you're burning. And then, if you want, you can respond to that information. You can share it. You can change your behavior based on that. So that's just as an example. We're still working on it. It's going to be released in a few months. The question of how information itself can help us to actuate the system through us. We respond to information, then we change our behavior. Now, at the other end of the spectrum, however, is actuating a system through physical things, through, say, architecture, through city building, to that type of physical. That's architecture is the oldest type of way to do that, to close the loop and to respond to the knowledge we have of the environment. So here I want to show you some examples. One example of a project we built where actually the space wasn't designed just as a space, but using a new type of projector by IBM, the space was designed around the ability of making a projection everywhere, so the space where everything around yourself would be a responsive surface. That's where the geometry was coming from. Or another project where we use water, like in this case, that was at the entrance of the World Expo 2008 in Saragoza in Spain. And the idea at the beginning was, imagine you have a pipe, and in that pipe that you see there, you got solenoid valves opening and closing very fast based on a computer input. And if you do that, then you can have like pixels made of water. What you can see here, you can write on it, you can show images, text, patterns. If you approach the wall, you can actually, it will open up to let you through. So it becomes almost like a living wall, a living material. Because of that, we got a commission to design the building. That was the initial renderings. The whole building is made of water, all walls. Then you can write on it, show images, you approach it, no doors or windows, it opens up to let you in. And then once you are inside, all the walls inside also expand and shrink based on people. It becomes a dynamic space. The roof is also covered with a thin layer of water. And then if there's too much wind, you can lower the roof, or at the end of the day, you can actually close the building and the architecture disappears. And this was before the opening. It was, you see, the guy with a puzzle face next to it, looking at what was happening. Here it was myself trying not to get wet, testing the sensor, try not to get wet. Well, I should tell you now what happened at one point when all of the sensors stopped working. You know, all the sensors are controlled to the computer crashed, and the building started responding to people. And we were all terrified. We didn't know what would happen. But actually, that night was one of the most fun nights ever, with thousands and thousands of kids from Saragoza came to play with the building, because the building that usually would respond to you, kept on doing its own crazy things. Patterns and images and holes in the water, and the way to engage with it became something different, like this. So for us it was interesting because as architects, as engineers, we always think about how people will use the stuff we design, but then reality is always a surprise. In this case it was a good surprise. Now a few other examples of actuation, physical actuation, we saw pixels made of water. Now think about that and imagine like pixels flying. Imagine a cloud of light flying, something like this. Very little helicopters that then can move in space and you can control them. You can buy them now they're very easy to produce, at just say $1 each. And then you just need to change the intelligence of the system and they can become something different. Something that can help you to create an immersive space, a more regular surface, but doesn't need to be a 2D surface, can be beyond 2D. They can actually then move completely in space. You can control the light. Or you can go to using them more as a display, as a traditional display. But much more interestingly is then when this display becomes like a 3D surface, and you can explore it, see it, move inside it. So from 2D, then again you can go to almost to a full three-dimensional object. So thank you. Some of that was real helicopters. Some of that was computer graphics. Here you can see a few of the real ones as well. 9 of them flying together. And, you know, they're quite magic. When there's no light, then you turn on the light, you see the things. But that for us really is how our environment can start to become actuated and respond to us. And I'll leave it down to Assaf to show you one of the projects in more detail on how we work at the lab and what this led to.
Thanks, Carlo. So continuing on the idea of actuation, here we created a digitized object that can allow people to traverse through cities in an easier way. I'm going to go through this in slightly more detail, also to show you how projects happen, how they evolve. This started from a partnership with the city of Copenhagen, with the Lord Mayor there in 2008. Here's the concept we developed.
Welcome to the Copenhagen Wheel, the wheel that turns your ordinary bike into a smart electric hybrid. Quickly and easily, with no additional batteries or wires. The Copenhagen Wheel allows you to capture the energy dissipated while braking and cycling, and save it for when you need a bit of a boost. Controlled through your smartphone, the Copenhagen Wheel becomes a natural extension of your everyday life. The Copenhagen Wheel is your personal trainer, sensing your effort level and providing you with real-time feedback about your fitness and exercise goals. The Copenhagen Wheel also enhances your experience of the city. It connects you with things a cyclist wants to know. Upcoming overcoming traffic congestion, road conditions, and pollution levels. Choose to keep your data, or share it with your friends and other cyclists through social networks like Facebook. As you ride, you also collect green miles. It's similar to a frequent flyer program, but good for the environment. Elegant, responsive, smart. A new mode of transport for a rapidly changing world. So turn on your life and turn on the city. The Copenhagen Wheel.
So let's take a step back for a second and look at how this project came together, how it evolved over time. This was a concept that you were seeing about a year and a half into the evolution of the project. In day one, when we started working on the project, first, like in any development, we wanted to define the problem. We went to Copenhagen, and we actually saw that there are more bikes than people there. For reals, it's not a joke. It's 1.0 something bikes per person. There's wonderful infrastructure for a riding bicycle. I think about 50% of the trips there are done by bike. But when you look into it in more detail, you see challenges. So the motorized transport there is one of the most energy intensive in Europe. Also, beyond a certain distance, people don't bike so much anymore. If there's a topographical challenge, people rather take motorized transport. So there was still a lot of room for improvement, and think about this also in the context of bigger cities that were built around the automobile. So the challenge we decided to look at is asking, how can we use digital technologies to attract more people to biking? Simple, almost one-liner that we wanted our team to be able to refer to this as the project evolved, constantly refer back to the vision. We started with a workshop. The workshop involved students from MIT, from multiple departments. We had architects and designers and people from electrical engineering and mechanical engineering, all working together to develop concepts, very early sort of seed ideas in response to this brief. These are the concepts that came out. Very, very sort of early concepts, a bit naive. There's a smart lock there, something that can help prevent theft in a smarter way. It's digital. There's an app there for coordinating how you meet up with your friends, something to collect green miles, and also an early concept of a fully fledged electric bike. We knew that we needed to put batteries on there, that there needs to be a motor, but look at it, it's almost nothing. It's just it's a dream almost. It's a concept that after we finished the class, we shared with the city, and they got excited about this. They said, okay, there's something in there. Now, there are many electric bikes out there. We looked at them. Nobody's ever put actually the batteries on the wheel. Nobody's managed to do that. So we said, okay, as with any idea you're not sure about, let's build it, let's see if it works. So after the workshop, we put together a team, again, a team of designers and electrical engineers, mechanical engineers, working together to build a first prototype. Started with a sketch, then we cut something in the MIT, there's a machine shop there, rather bulky prototype, pretty much just wrapping batteries around a motor and with some wires and quite a lot of solder, putting it together on a wheel. We put it on the bike then. It had a control, like when you ride a motorcycle, a throttle wired to the handlebar, and we took it to Copenhagen to show it to the mayor. She liked it, and she asked, well, can you actually make 15 of those so that the mayors I host here in the climate summit at the end of December 2009 will ride them? So you got a bit scared, we're academics, we don't usually build things that people actually use. And all right. So we went back and we said, okay, back to the drawing board, we need to revisit the brief. This is an interesting challenge for us. So we put together a set of tasks here. This is a lot of you are designers, so you've seen a brief before, but really the main task, what we wanted to see is something that's wireless, something that's plug and play that you can stick on any bike. You just, like a motion like this and your bike is transformed. This was sort of, again, we were dreaming. We wanted something that can capture your energy when you brake, something where the data it collects can go online so that you can write apps with it, something that can also collect information about how you move through the city, something that can enhance your experience of mobility altogether beyond just propulsion. We went back to the drawing board. We put together quite a few sketches at the beginning, and there was a team of engineers that needed to also take part in selecting motors and things like that. There were mechanical fittings, some things that are very detailed. Working together, designers, engineers, people who understand cities as well. So these are all the components that needed to come into this together. We had a hub, but we didn't know how to connect it to the rim, right? We wanted to work with any bike. So we started exploring all sorts of spoking methods. This was a first iteration, it looks rather crappy. But again, we kept on pushing on this. It looked better, but it failed. It broke because there was too much torque down close to the center. So we flipped it around. We said, oh, does it work? We didn't know. We said, okay, let's just prototype it. We built something out of cardboard here with a laser cutter, very simple, wires to spoke it up. Then we 3D printed it, a bit more rigid, wired it up. We wanted it to fit on any rim, so we just took normal spokes and bent them. Put it on a thing, see if it works. He was a bit skeptical. Then we wrote it, and it worked. It worked. This was a plastic 3D printed thing that is, it's even fragile to hold, but the system was designed to hold in tension. And with the spokes being in tension as well, you could even ride that thing. So we were quite happy. Then we kept the development. We went back to our brief and said, okay, but this thing needs to be controlled wirelessly. So we put a Bluetooth chip inside the wheel and started thinking about a mobile phone application. Something that you can use to control the bike as you move around, something that could control how much the motor assists you, something that can help you actually analyze your trip so you can go back and see where you've been, how many calories you burned. Something that can maybe allow you to collect green miles and somehow incentivize people to ride more through the city. Then we wanted to even push it a step farther. This idea of embedding the bike in a network that's slightly more complex in the city, embedding it in a new way, in a way that bikes could actually share a task together, maybe do something positive for the city together. We looked around. Sensor-enabled bikes are not really there yet. But we found this little sensor that we decided to implement inside the wheel. So we stuck it in there. It measures CO, NOx, temperature, and some noise levels. Look at, this is, I think, 12 people riding in Copenhagen together. And you can generate from the bottom up these beautiful maps that tell you air quality on the street level. This is really what you want to measure, not something up 30 meters in the sky. I think it took 2 weeks, and they covered most of downtown just riding around. And then we were pretty much done with the design. We had to start machining this and building them. So pieces cut, we had all the components machined, detailing of how to fit it all together. The software was written for the mobile phone, electronics was developed. Then we put it on the bike. We also colored it in the Ferrari red. That you can go wrong with that. First prototype arrives in Copenhagen. We wanted to create suspense, so we put it in the box and until the unveiling. And this is Carlo actually showing it at the beginning of the climate summit. The Lord Mayor there took it for a test ride. Here is Rit Bjargo, Lord Mayor back then, riding it together with David Miller, who was not the Lord, but the Mayor of Toronto, back in 2009. The bike is circumstantial. You can fit it on any bike.
I will follow.
One of the things that was most important, I'm riding with a flat tire, by the way. I don't know if it's noticeable. One of the things that we really wanted to make sure we keep is the original biking experience. No throttle, no nothing. We wanted you just to be able to ride and feel like you lost half your weight, or like there's no uphill, all of a sudden it feels flat.
Excellent. This bike is fantastic. It's incredible. It takes no effort. You see my bike? You start pedaling and the motor takes over. And then it will tell you the air quality, temperature.
We didn't coordinate the scarf, by the way, with the color.
Incredible. It's amazing to see an idea come to fruition like that.
Think about the process that we looked at here. You could define this challenge as, let's put a motor on a bike. Then it's mostly a question for engineers. Or you could look at it in a slightly broader way and ask, how can we attract more people to biking? How can we actually let cities like LA or Beijing or San Francisco that were designed around the automobile become more relevant for biking? Then it's a slightly different question. It becomes a question that requires people who understand cities, people who understand design, who can make it attractive, something sexy that people want to own. But also those mechanical engineers and electrical engineers that could then help design those parts that need to come together. So just an example of how a project evolved at the lab. Thanks.
Yeah. Thank you. And we just had a couple of slides just to conclude with this. We just wanted to share with you some of the things we learned over the past few years. We started the lab like 7 years ago, and we've been, evolving and changing and growing. So just a few things. We believe that there's a very big change that's happening, and it's really not just about design, not just about architecture, cities. It's really about knowledge. Till a few years ago, till a few decades ago, we still thought that knowledge was something like this. This is still the vision of St. Thomas. It's still the fact that you could do a summa and put everything in the right spot, and you combine all of that and classify it. We know today that's not the case. We know today that we're looking at something like this. That's a beautiful map. It was on the cover of Science magazine, and that map is based on 800,000 papers and how all of the papers are linked with each other. And you see that there's no boundaries. There's all the fields coming together, all the people working together. There's people in astrophysics working with brain research. There's all these new links that are happening. And we think that this is very beautiful. That map actually looks much more like knowledge as we know it today. Knowledge post-internet, as everything comes together in a seamless way. There was also some research in Nature that was published, I think, 2 or 3 years ago, where they looked at the most influential papers published in one of the top scientific journals, both 50 years ago and now. Now, a few decades ago, the most influential papers were still usually single author. It was one person actually authoring that. It was still the idea that it's almost going back to Newton. The idea you sit there, you're on your own, the apple falls on your head, you got a great idea, you write about it, and that becomes an important thing.
That's how I work.
It's not an apple. But today, actually, the most important papers being published, the ones that are cited most, are actually the ones that are done by many authors coming from many, many disciplines. And we believe that the same is now happening with design. Design used to be like this. That's the most striking image you can imagine. That Le Corbusier, almost 100 years ago, showing the Plan Voisin to Paris, the Plan Voisin, actually demolishing most of the city, leaving just Notre Dame and a few things, as kind of residues of the past. And this kind of hand of Corbusier, the hand of the architect, the hand of God, top down, showing his design. We think today is something different. It is not, people used to say that a camel is a horse designed by a committee. When you put people together, instead of getting the horse, you get the camel. We think today we can go back from the camel to the horse. And the way we do that is really by coming together and bringing different people. Here was an editorial, the editorial for Domus magazine. They asked us if we could write the introductory article to an issue on open source architecture. And what we decided was, if that is the case, let's also do this together. Also, in an open source way, try to do the editorial together. You can see some of the people who collaborated. Hans Zurich was one of them, Paolo Antonelli or John Maida, Nicolas Negroponte, and many others then online who expanded on it. Actually, here you can see the picture of the initial people who contributed to that. You see my glasses, Hans Zurich's face a bit, Paolo Antonelli. You can recognize all of us layered on the top of each other. So we believe that that's really a big change that's happening today. We still don't know how it's going forward. We still don't know how it works. It's really about many people, many disciplines all coming together. And there was a person who wanted to come and visit our lab just a few months ago, a person called Luca Simeone, an anthropologist and an interaction designer. And he wanted to come to us and study us a bit like monkeys, to see really how the process happens, how we do things. And I just want to share with you, he came, this was his brief.
Welcome. My name is Luca Simeone. I'm a cultural anthropologist, and I carried out an ethnographic study of MIT SENSEable City Lab's organizational culture in order to understand if there were components that foster transdisciplinarity.
And he stayed, he observed us, and he looked at what was going on. And after a few months when he left, you find all of this online, he documented everything, so it's interesting for us as well. He concluded, I don't know, It's very messy, but it works.
Of course, it's not pure chaos.
Thank you.
Thanks a lot, everybody.